It helps you to analyze problems on the system like weighing faults. What you can see here is, for example, this customer we have real data from 2016. He had 439,000 weighings, while 45,000 weighings had a mistake. This is more than 10%, so this is quite much. When you see it more detailed, you can see most of the tolerances are, most of the faults are tolerance faults, a few throughput, and also just a few of the dosing time faults. Principally, when you see it over the year, it's more than 75% of the faults are tolerance faults, and that's quite much. So we can see on the next picture that when we check only one component for the scales, what's the reason for? You can see we have this we have here the maximum and the minimum range, and most of the weighings are close to it, with some larger with some larger discrepancies, and we have to find out what's the reason for. On this picture, you can see no matter on which amount you're weighing, it's the weighings are very close to each other, but they are on the lower end of the minimum. If we rise up the let's say the dosing amount, so we get closer to the set point, most of the weighings wouldn't have a problem. They would be inside the range, so we don't get any problems on the system. It's running through. We are pretty fast, and the faults which are, let's say, on the upper level get a little bit more, let's say, exceed more than normal, but these are already some weighings which are not that good. So the customer has to react anyhow.